In armored warfare, an autoloader or autoloader is a mechanical aid or replacement for the personnel that load ordnance into crew-served weapons, such as tanks and artillery. The term is generally only applied to larger weapons that would otherwise have a dedicated person or persons loading them. An autoloader, as its name suggests, extracts a shell and propellant charge from the ammunition storage rack/compartment and loads it into a magazine, if the gun has one, or directly into the chamber of the gun if it does not. It can and often does replace a human loader. By automating the loading process, it can streamline and speed up the loading process, resulting in a more effective fighting machine. In addition, by removing the need for one, or more, crew member, the overall size of the vehicle can be reduced, which in turn reduces the amount of surface area that needs to be armored, and thus a vehicle designed to use an autoloader can benefit from a significant decrease in weight and size. Also, since an autoloader can take up less volume inside a tank than a human, it potentially allows for a lower profile, making the tank harder to hit. Autoloaders are mechanical devices, and therefore their reliability depends on how well they are designed, manufactured, and maintained. History. Autoloaders were developed at the beginning of World War II. Their first combat use was in tank buster aircraft such as the 75mm caliber board cannon BK-7,5 cannon-equipped Henschel HS-129B3. Every Soviet and Russian-derived tank since the T-64 main battle tank has used an autoloader. Their use has been mostly shunned by American and British tanks, although the American T-22 medium tank was one of the first to use an autoloader. Naval. In the modern era, autoloading is common on any large, 3-inch, or 76.2 mm caliber or greater, naval gun. The size of the shells, when combined with the more elaborate autoloading facilities available in the wider spaces of a ship, makes an autoloader much faster than human loaders. For example, the US 5/38 Mark 12 can load about 20 rounds per minute. The Soviet/Russian AK-130, twin-barrel 130 mm, using autoloading, can achieve up to 40 rounds per barrel per minute. The Italian 127mm/5 compact has similar performance. The largest caliber autoloading naval rifles were the US 8/55 Mark 16, deployed on the three cruisers of the Des Moines class in the late 1940s, and the 8/55 Mark 71 tested aboard the destroyer USS Hull in the late 1970s. Both weapons achieved a rate of fire of 12 rounds per barrel per minute, compared to 3 to 4 rounds per minute for the preceding hand-loaded weapons. The advent of jet aircraft, and the rate of fire required to engage them, hastened the adoption of automatic loaders on naval artillery. Development of the loading systems was often problematic, and reliability was seriously compromised in many cases. The US 5/54 Mark 42 was derated from 40 rounds per minute to 34 to improve reliability. The Soviet/Russian AK-130 was so badly delayed that the missile cruiser Kirov, later Admiral Ushakov, was forced to use two older weapons in its place. The US 3/70 Mark 37 actually spent more time in design, 13 years, than in service, 12 years, due to severe unreliability. These problems are largely of the past and the field has advanced a great deal. Ground vehicles. Rate of fire. A modern autoloader for a 120 to 125 mm caliber weapon in good condition can achieve about 10 to 12 rounds per minute. This rating may or may not include the time required to bring the gun to the appropriate loading angle, if required, and then bringing it back up to firing angle after loading. The autoloader on the cancelled Object 640 Black Eagle tank was supposed to have up to 15 rounds per minute rate of fire. It is considered atypical to engage more than a few targets per minute in a tank. The autoloader may also have an advantage while traveling over rough terrain that may jar a human loader enough to disrupt his loading cycle. For weapons above 127 mm, the increased weight of the round pushes this issue decisively in favor of the autoloader. For self-propelled artillery with calibers of around 155 mm, for example, autoloaders can typically achieve 8 to 12 rounds per minute, while a human loader, S, can typically achieve 4 rounds per minute. For sustained bombardments, this may not be so important. Sustained firing rates for artillery are typically only 1 to 2 rounds per minute, but the rapid fire capability is vital to shoot and scoot tactics to deliver enough fire and then avoid the rapid counter-battery response provided by modern counter-battery systems. On the other hand, even during sustained bombardment, an autoloader could be useful, as the fatigue issues of loading an artillery piece for hours. A 155 mm projectile weighs ca 50 kg, do not affect them. In addition, an artillery with an autoloader and powerful fire control system can utilize multiple rounds simultaneous impact technique, which allows to burst fire several shells, varying their propellant charges so all of them land on target simultaneously. Survivability. The most common autoloaders store their ammunition in the turret basket, increasing the possibility of a catastrophic explosion should the armor around the hull or turret be penetrated. More armor protection and isolation/separation of the ammunition from the crew compartment has traditionally been available in tanks with a human loader, which can decrease the possibility of cook-off, or protect the crew in case of an ammunition explosion. For example, the M1 Abrams was designed to protect the crew from cook-off, which is accomplished by storing the main gun ammunition in a compartment at the rear of the turret. The compartment is separated from the crew by a power-operated armored door, which is only opened for a couple of seconds each time the loader needs to grab another round. The top of the compartment has special roof panels that are armored against outside attack but are much less resistant to pressure from inside, so that if the compartment is penetrated by enemy fire, the panels will vent the explosion generated by the ammunition while protecting the crew. Other Western designs from the later Cold War era to the present with manual loading have similar protective features. In contrast, the Soviet tanks of the Cold War, which employ autoloaders, store the ammunition on a carousel in the middle of the crew compartment, where any penetration by enemy fire is likely to incinerate the crew and blow the turret right off the top of the tank, known as the jack-in-the-box effect. However, some newer autoloader designs also store the ammunition in an isolated compartment in the turret bustle, with blow-off panels on top and the ramming mechanism underneath or in the middle. This allows for much better crew protection, but is disadvantaged because the loading mechanism located in the ammunition compartment reduces the available space and number of rounds that can be carried considerably compared to a similar-sized compartment without machinery. With such a design, the loader crew member can be eliminated, but only half the ammunition can be carried ready, in the compartment with the autoloader. Therefore, such a tank usually stores additional ammo in compartmentalized storage at the bottom of the fighting compartment, like older manual loading tank designs. This storage can be surrounded by water, and compartmentalized to some extent, but the reduced crew must still transfer this ammunition to the autoloader at some point. However, such a design can also allow for the rapid replacement of the autoloader and reloading of the ready ammunition by making the compartment at the rear of the turret a modular component that can be easily replaced with appropriate support equipment, similar to how the US MLRS system is reloaded, but possibly even faster. Another possible advantage is that the door that separates the turret can only be large enough for one round of ammunition to slide through, rather than extending across the entire rear of the turret as in the case of the M1 Abrams. This could save additional mass and reduce the power necessary to operate the door, by using less massive armor for the same level of protection, since it would be part of the turret instead of a sliding component in a heavy frame. The disadvantage of need to keep most of the ammunition close to autoloader can be actually turned into an advantage by utilizing unmanned turret design and / or crew capsule. In this case, all the necessary ammunition can be kept in direct access to the autoloader, without caring for the safety of the crew, because crew compartment is completely separated from the autoloader and ammunition. Modern examples of this design is Russian MBT T-14 Armata and Polish light tank PL-01. Size. Autoloaders are often implemented in an attempt to save on tank size. The T-64 is an example of this. The current generation of tanks using autoloaders, Russian T-90 and T-14, Japanese Type 90 and Type 10, Chinese Type 98, Korea K-2 Black Panther, French Leclerc, Pakistan Al-Khalid MBT, all weigh between 45 to 55 tons. Tanks that do not use autoloaders tend to weigh in the 55 to 70 ton range, American M1A2 Abrams, German Leopard 2, British Challenger 2. Fatigue reduction. The replacement of the loader and gunner with a commander and driver could allow crew members to rotate shifts. This would enable continuous operations on the battlefield. Though in some retrofit cases, Abrams tank for example, there is nothing in the fitting of an autoloader that requires the removal of the loader. In such situations the autoloader frees up the fourth crew member to support the other three full-time, instead of just part-time when they are not doing their main job.
Please subscribe and thanks for watching.